So Pythagorean theorem, so on your title, the word theorem here, all theorem means is a law of mathematics. Okay, it's just a fancy word for law. Right, Chris? So underneath the word theorem, I'm going to put law. And Pythagorean, that's just a Greek philosopher. He was a Greek philosopher and mathematician. His name was Pythagoras. So they named this law after him. He didn't invent this law, he just kind of stumbled upon the truth of it. And because he popularized the truth of it, they named it after him. Pythagoras was his name. So they call it Pythagorean theorem, or Pythagorean law. And here's what the law says. Before I get into what the law says, we first have to figure out, we have to talk about a right triangle. Go ahead and define a right triangle. I'm going to write the word right triangle and put a triangle that has a right angle as one of its interior angles. A triangle that has a right angle as one of its interior angles. And you can see that big fat right angle right here in blue. Now it's black. Remember, this is 90 degrees, right? So if you have a triangle with 90 degrees in it, we call that kind of triangle a right triangle. The two sides that make up the 90 degrees are called legs. The third side that's always opposite the 90 degrees, the longest side, is always called the hypotenuse. So go ahead and mark up your paper there. Okay, so what is the law? What is this theorem that I told you about? Okay, we're going to write the theorem out now. The theorem has to do with right triangles only. There's something very special about right triangles that this guy Pythagoras stumbled upon. It's actually one of the most important theorems that has transformed the world in terms of trigonometry, engineering, triangulation. There's smartphones that are hooked up to satellites. The basis of that technology is trigonometry, which is Pythagorean theorem. This wouldn't be possible, in other words, without this, is what I'm trying to say. And here's what this theorem says. This is what this law of mathematics says. It's a very mysterious law. Check this out. Go ahead and put a star on your notes. And here's the law, right here. Underneath the squiggly right here, or above the squiggly. In a right triangle, the sum of the legs squared is equal to the hypotenuse squared. I'm going to draw a simple right triangle, another one, and write out the law. So this is the law right here. This is the theorem. What I have in the star. This is the theorem, this statement. In a right triangle, that means any right triangle. In a right triangle, the sum of the legs squared is equal to the hypotenuse squared. Okay. So look at, I'm going to write out in an equation what this law is saying, and you're going to write it out with me. The sum. Can't get it to see its sum. What does sum mean? Adding stuff, huh? The sum of the legs. Okay, so that means there's always two legs in a right triangle. Remember the ones that make up the right angle? So look at, I'm going to write it out as an equation. Watch this. One leg to the second power plus another leg to the second power, write this with me, is equal to, okay, the hypotenuse squared. I'm going to put HYP, the hypotenuse to the second power. That's the law that Pythagoras stumbled upon. It's always the case, no matter what. Pythagorean theorem. It transformed the world. Okay, so on the picture that you and I just drew right here, what are the legs here? What side would be the legs? A and B. So another way to write it out, the Pythagorean theorem, instead of writing leg, hypotenuse, typically in a math textbook and math communication, it's always a squared plus b squared equals c squared. I'll write that down. Notice how A and B are the legs here. Look at, I'm highlighting them in blue right here. This is a leg, and then C is your hypotenuse. The hypotenuse is always the longest side of a right triangle. So let's try using this law to solve some problems now, some real life problems. Here's example 1. Let's solve for x. Go ahead and copy this one down. Solve for x. Okay, so how do I know this is a right triangle? What is it about this triangle tells us it's a right triangle? 90 degrees. It's right here. So I already know it's a right triangle, so I know the Pythagorean theorem will apply to this triangle. See, triangles come in all kinds of different shapes. Look at, there's a triangle. Here's a triangle. Excuse me, I got the floor, thanks. Here's another triangle. Pythagorean theorem doesn't work for any triangle. It only works for a right triangle. Now, whoa, that was crazy. Okay, let's try it. The law says, the Pythagorean theorem law says, a squared plus b squared equals c squared. Write that out with me. A and B are the legs, and C is a hypotenuse. What would be my legs here? Anybody? 6 and 5. The legs always make up the 90-degree angle. So look at what I put. 6 squared plus 5 squared equals x squared in this case. Let's solve for x. Exactly. 6 times 6 is not, no, 6 to the second power is not 6 times 2, it's 6 times 6. 36 plus 25 is x squared. Let's see here. 36 plus 25, 61, huh? 61 equals x squared. How do you get x by itself? Right, so if x is to the second power, this is really asking what number times itself becomes 61. To get rid of the second power and get x by itself, we want to square root both sides. We take the square root. I trust you've seen square root before. Square root means what number times itself becomes that. Now what I'm going to do is I'm going to get my online calculator, which you have accessible on your own laptop. Look what I did. All you got to do is type in online calculator. You got your calculator. It's touchscreen too. So look what I'm going to do. I'm going to hit square root of 61. Here's square root symbol. 61. Okay, equal. So there is no such number times itself that becomes 61. There's only an approximate number. It's 7.8 blah blah blah. It's an infinite non-repeating decimal. So 7.810024968, and it keeps going. It just stops here on the screen, but it actually keeps going forever. So we call this an irrational root. It's not a perfect square root. The square root of 61. So what we're going to do is we're going to round off to the nearest tens place. Approximate. We're going to approximate. So the square root of 61 is approximately 7.8, the nearest tenth. I look at this decimal, look to the right of it. If this is not 5 or bigger, it just stays the same. So back over here, what is x then? Here we go. X is approximately, okay, I put the approximate symbol because we have to approximate, 7.8. So we solve for x using Pythagorean theorem. So this hypotenuse ended up being approximately 7.8. This is the approximate symbol. About 7.8. Then it's equal then. So in other words, what if this was like the square root of 25? Is that what your question is? Let's say you had x squared equals square root of 25 or 25. In this case, you take the square root of 25 is 5 on exactly 5. So x would be exactly 5 there. You don't have to approximate. Okay. Otherwise, we have to approximate. Next week, I'm going to talk to you about simplifying irrationalness, but not for this week. It'll give you guys nightmares. Example 2. I'll write this one down. All right. Diagonals. This is a right triangle? Yeah. How do you know? 90 degrees. So I know Pythagorean theorem works. So I'm going to state my Pythagorean theorem. A squared plus b squared is c squared. One leg to the second plus another leg to the second is equal to hypotenuse to the second. All right. Robles, what will be my legs here? What will be my two legs? 7 and x. So here's what I'm going to do. 7 squared plus x squared equals a hypotenuse. The hypotenuse is always opposite to 90, in this case 14, equals 14 squared. Look at that. Classic. Here we go. 49 plus x squared is 14 to the second power. Let me get my calculator out. 14 times 14. 196, thank you. So 196. All right, we got to solve for x now. Let's get x by itself. Let's see, you guys taken math 1 before. We need to get x alone. X is on the left side of the equation. How do you suppose I get x alone? Right, let's get rid of that 49 first, from both sides. Look at it, from the left side and from the right side. Look at this, you guys. We haven't done any algebra yet for a whole week in this math 2 class. All we've been doing is area, perimeter, and geometry, right? And volume and surface area. Now look at the first equation right here. 196 minus 49. 196 minus 40. 147? You're awesome. Almost done. Square root that puppy, right? Square root, you get x alone. So it gets rid of the second power. It undoes, it offsets the second power. So x is approximately to the nearest, just go to the nearest 10th, not the second decimal, the first. So 12.1? Yeah, 12.1. Approximately 12.1 to the nearest 10th. That's it. We solve for this leg. Okay, we solve for the leg in this case. Sure. Last example. Last example. Easy lesson, I trust. This is actually the last lesson of the week. Tomorrow we're gonna play Jeopardy before the test. We'll have the guys go heads against the ladies in a Jeopardy game. It's gonna go down. It's gonna be awesome. Oh man, this guy's. Where's some confidence, man? We're gonna lose.
We got him sleeping with.
Oh shit, you're right. Never mind. You are gonna lose. This guy too. Alright, here we go. It's a right triangle. It's got 90 degrees. So, I know this is true. I know the Pythagorean theorem holds for this triangle. Cortez, what are my legs here?
9 legs.
Beautiful, here we go. 9 squared plus x squared is 21 squared. Remember, when I have the floor, you're not supposed to have your phones out. I guess some of you are just addicted to your phone. You can't, you're incapable of putting it away. But it's going to cost your grade. Knock yourself out. Let's see, 9 squared, that's 81, right? Yeah. 21 to the second power, anybody? 21 times 21? You're awesome. Let's subtract 81 now to get x alone, right? We're getting x by itself. So x squared is... crap. That's what it is. You sure? Sounds good to me. Let's take the square root to get x alone now. It's gone. X is approximately, hit it, Jim. Square root of 360 to the nearest 10. 18.0. 18.0.
I think it's 19.0.
What?
You know how 9...
Tell you what, let me punch this puppy in here. So square root of 360, here we go. Square root 360. You're right. So look at, I'm gonna round the nearest tenth. It's already a 9. I looked to the right of it. This is 5 or bigger, so this goes up to a 10. So it's gonna be 19.0.
I'll see how it right.
Yeah, I just said that. So 19.0. 19.0. Use the last 10 minutes of class to finish up any assignments. We're done for that.